Welcome to Lab 1, Charged Tapes. The purpose of this lab was to observe interactions between two charged pieces of tape and determine the charge of each tape. The model created in this lab modeled the two pieces of tape as point charges, one above the other, and the forces, mainly gravity and the electric force, acting on each one. Some fundamental physical principles observed in this lab include Newton's second law, the momentum principle, the electric force, and gravity. The main result of this lab is that both pieces of tape have a charge of about 5.686 times 10 to the negative 9 coulombs. Newton's second law says that the force on an object is the mass of the object multiplied by the acceleration of the object. The momentum principle is essentially an altered version of this principle. It states that the change in momentum in a system is equal to the net force applied multiplied by the time. I did not directly use these principles in the lab. I only used them to realize that because the momentum of tape B was zero, as it was not moving, gravity and the electric force were at equilibrium. The electric force states that the electric force acting on one charge or the other is given by 1 over 4 pi epsilon 0 times the charge of one charge multiplied by the charge of the other charge, divided by the squared magnitude of the distance between them. Essentially, like charges repel and opposite charges attract. The force of gravity can be calculated by multiplying the mass of the object times the acceleration due to gravity on Earth. Some assumptions made in this lab include assuming that both pieces of tape have the same charge evenly distributed throughout the tape. The charge of the tape is concentrated into a point charge in the middle of the tape, and we ignored air resistance. In the experiment, I ripped various pieces of tape off of a base tape in order to charge the tape pieces. I then observed how the charged tape interacted with my hand, a negatively charged pen, and to each other. The charged tape was attracted to my hand and the negatively charged pen, but was repelled by another charged tape. This means that the charge of the tapes was positive. The length of each tape was about 0.18 meters, the weight of each tape was about 0.00018 kilograms, and there was about 0.013 meters of separation between them. The system includes tape B, and the surroundings include tape A and the Earth. Using Newton's second law, I realized that the force of gravity is equal to the electric force, and since we could easily calculate the force of gravity, I could calculate the electric force as well, and therefore calculate the charge of each tape. In the model, I calculated the force of gravity on tape B as seen in lines 9, 10, and 11, and then added a vector representing this force. I then created a function to calculate the electric force and calculated the electric force acting on tape A and B. I then created vectors to represent these forces. I used the charge calculated in the experiment. I used the fact that gravity and the electric force are equilibrium to set the forces equal to each other. I already had the distance between the charges, so I could solve for charge. I got that the charge is equal to 5.686 times 10 to the negative 9 coulombs. I also calculated the deficiency of electrons in the tape. By dividing the charge of the tape by the elementary charge, I calculated that the piece of tape lost about 3.5 times 10 to the 10 electrons. The ratio of electrons lost to total number of atoms was about 1.06 times 10 to the negative 7. Using only the charge calculated in the experiment portion, we were able to simulate the experiment perfectly. As seen in the picture, the forces on tape B balance out. In the picture, tape B is the green charge, and the force of gravity is the cyan vector, and the electric force is the orange vector. Because the same values were used in the experiment in the model should have modeled the experiment perfectly, and it did. The only differences are a result of the environment in which the experiment was made in, and sources of error in the experiment that were not taken into account in the model. Possible sources of error include that the tapes lost charge over time. They were made at different times, so it is likely that each piece of tape had a different charge. Also, the AC was on in my room, which moved the tape slightly. If electrons had a positive charge and protons had negative charge, nothing will change. Like charges still repel and opposite charges attract. The interactions I saw would still be the same. The only difference is that the charge of each tape would just be negative instead of positive. If my hands touched the charged tape, some electrons from my hand would move towards a positively charged tape, making the tape neutral again, which is why it was imperative that I did not touch the tape directly. Thank you and have a great day.